In preparation for the solar installation, we always pre-assemble the superstructure of the solar installation on the ground. With the main frame of the support structure being assembled, the cradles being attached to the main frame, and then always ensuring that the front horizontal member is installed on top of the other mainframe components. It is also important to note that your bolts should always be facing to the inside of the frame before we then start to assemble the rest of the superstructure. The diagonal braces are fitted to the main frame in order to add stability, to ensure that when the vertical support is added to the structure, that it does not collapse and then improve stability of the framework. Once we have put the main frame together with the cradles in place, it is now time to put the vertical support in position. The vertical support will not only raise the cylinder and the collector to the correct angle, but it will also assist with stabilizing the supporting structure. Once the vertical support has been attached to the main frame, it is now time to adjust the diagonal braces so that we can get the correct elevation of the structure. When we have attached the diagonal braces, we have the option of adjusting the inclination of the collector so that we ensure that it has maximum exposure in relation to the weather conditions in Cape Town, so that the sun has maximum radiation on the solar collector. Once the collector has been installed in position in reference to the manufacturer's manual, we are now ready to install the tank into the cradle. Once we have put the tank in position, we are now ready to secure the tank onto the frame. Once we have secured the tank in position and securely fastened it to the collector, we are now ready to install the piping in the correct order in reference to the manufacturer's manual, where the highest point will be connected to the hot water inlet side of the panel and cold water supply will enter at the bottom of the collector. When cutting your copper pipe, ensure that the pipe is securely fixed inside of the rollers on the cutter. Turn a quarter, rotate thrice to ensure that the pipe cutter gradually cuts clean into the pipe. After you have cut the pipe, use the deburring tool to remove any burr that is on the inside of the pipe. Once you have removed the burr, you are ready to do your connection. Once we have installed the tank and collector in position, we are now ready to collect the solar outlet from the tank to the bottom of the collector. For ease of maintenance, we always use compression type fittings around the collector and the cylinder. To prevent any leaks, always ensure that you fasten the compression type fittings correctly. Once the fittings have been connected to the bottom of the collector, the insulated section of copper tube can then be fitted to the solar outlet of the tank. Once again, a compression type fitting is inserted onto the solar outlet side of the tank. and then properly secured by using the correct fixing tools. After this, a stop end can be fitted on the top side of the collector and fastened into position. The thermostatic mixing valve is then put in position on the top of the tank. The compression nut is slid onto the pipe, followed by the compression ring, and then the thermostatic mixing valve slid into position. It is then properly secured using your fastening tools. And the cold water draw-off point will be connected to the outlet side. Water to the draw-off point is then connected to the thermostatic mixer, and all pipes properly secured by using the correct tools. Once the thermostatic mixing valve has been put into position, it can be adjusted to the correct temperature setting. After securing the drain cock to the cylinder and fitting the supply pipe to the thermostatic mixer, we are now going to fit the isolating valve to the cold water storage tank at the top of the cylinder. This isolating valve will ensure that when we need to do maintenance, we can simply shut off the water and continue with maintenance work. A 15 millimeter copper pipe is fitted to the inlet side of the isolating valve and will be connected to the main supply. We will now fit a stop end. We will now connect the hot water outlet from the solar collector to the cylinder. Ensure that your compression type fittings contain the compression nut and the compression ring, after which you will fit the fitting onto the collector. Section of copper tubing is then prepared to be connected between the collector Once the compression type fittings are properly fixed to the connection pipe between the collector and the cylinder, it always has to be secured with the correct tools. The installer takes care not to over tighten the connections. Once the installer has secured the pipe connecting the collector and the cistern, he will fit a stop into the bottom of the collector. Fitting the stop into the bottom of the collector ensures that when water enters the bottom of the collector, as radiation heats the water in the collector, it will gradually rise to the top of the collector and exit via the top of the collector into the hot water cylinder. The installer will ensure that all of the necessary pipes is properly lagged so that we do not have any unnecessary heat loss. Once the installation is completed, the installers will check the manual to ensure that all of the relative components have been accurately installed. Cold water supply going in to the cold water cistern, traveling out via the drain cock towards your thermostatic mixing valve, down into the collector and back up into the hot water cylinder. The installers will also check that all connection points are properly secured. If there are any leaks, they will tighten it at this point, after which cold water supply will be turned on and the system will be commissioned and ready for use by the consumer. In this video, the solar installer will illustrate the flow diagram of water as it enters into the cold water system from the mains, then towards the thermostatic mixer, out via the supply pipe to the collector, and then down the supply pipe into the collector. As cold water enters the collector from the cold water supply from the hot water cylinder, due to radiation, the cold water will change temperature and density, which will allow for the thermosiphon effect, where cold water heats up into hot water and then rises to the top of the collector, where it will then exit at the highest point of the collector and return back into the hot water cylinder. At this point, the hot water will enter the hot water cylinder. Inside of the hot water cylinder, we will have different layers of density, cold water at the bottom and hot water at the top. Hot water will then exit the cylinder through the thermostatic mixer, which mixes with cold water as well, to give you water that is a safe temperature to use for the consumer.